Number 6, f is decreasing from negative infinity to negative 6. It is decreasing from negative 6 to negative 3. And it's also decreasing from negative 3 to 0. And it's increasing from 0 to infinity. Number 8, f is increasing on negative infinity to negative 2. Decreasing from 0 to 4 and increasing from 4 to infinity. Oh wait, I think I read the wrong problem. Hold on, time out. That was 7. Those numbers don't match at all. Number 8 is increasing on negative infinity to negative 4. And it's decreasing from negative 4 to 4, increasing from 4 to 5, and decreasing on 5 to infinity. 10 is increasing from negative infinity to positive infinity. 12, I gotta flip the page, give me half a second. What? Okay.
I accidentally put an X on 12 before we even read 12.
I see. Oh, you expecting that you got that one wrong? Oh no. This is 1, 4, yeah? 1, 4. 1, 3, 1, 4, number 12. So yours may be like the rounding or whatever, or the way the calculator spits stuff out, or those kind of things. The numbers may be slightly different, or you may have rounded in a different place. I don't know whether it says where to round to. It does not. So it might be slightly different. So as long as they're within a solid margin of error, then you're great. Number 12 has a relative max at negative 0.52, 0.28. And 0.68, 0.43. And then it has a relative minimum at 0, 0, and 2.24, negative 9.1. Number 14 has a relative minimum at negative 2.45, negative 58.79. It has a relative maximum at 2.45, and 58.79. It has a relative minimum, 16 has a relative minimum at negative 1.08, negative 8.58. It has a relative maximum at 0.73, 4.29. And it has an absolute minimum at 6.35, negative 268.71. That's the last one we did, right? Okay. What questions do we have on those? 14, 8, and what did you say, Bree? 6.
6 works too.
6 works too. Okay, so let's start with 6 and then see where we go from there. So number 6 is a picture. So let me shove it up on the screen, and we'll flip our camera around. Actually, I may not care. In fact, I'm not going to waste my time doing it. So if you happen to be somebody on the internet that's watching these videos, and I have slighted you by not putting it up on the screen, let us know in the comments and we'll fix it for you later. Okay. But since I don't think you exist, I'm not going to worry about it. Okay. So number 6 is a picture. I do need to put it up on the screen for you guys so I can point at it and make grunting noises.
Did you start the video?
I did start the video. I even started the audio, which I forgot to do last class period, but at least all of my students were there, so, whatevs.
Nice.
Hello, there we go. All righty. So, tricky. This is the increasing, decreasing one, yeah? Is that what it's asking about? Okay, so it is increasing from negative infinity to there, right? And decreasing from there to wherever this asymptote is, right? Excuse me. And then it is decreasing from that asymptote to here, wherever that is, and it's increasing from there to positive infinity, right? So we understand at least we can say it's from that point to that point, right? Okay, so then you can shove it in your calculator and figure out where all three of those important points are this one, and this one. Actually, I'm pointing to here, but it's actually probably more like right there-ish. Looks like to me, something like that, whatever it is, negative 3 point something probably. And yeah, so this point and that point. So we need to know where it's changing. So shove it in your calculator. In case you do actually exist, I'll write the equation on the board. Doing these recordings almost feels like I'm schizophrenic. Who are you talking to? Probably nobody.
Oh.
How do I make another thing?
Tab.
No, but like a whole nother page.
You go home and you hit new. So you're in just Scratchpad right now. If you want to leave that other one there, you hit new, and then you can save the one that you already did or whatever else and all that kind of stuff.
Okay.
You can also cancel and then go back to the graphing part. So in your graphing part, you're in Scratchpad. Just kidding. So you already have, so I got to this page, right, so there is already another document that exists currently. And so I think if we hit, let me double check. If I lose something, then, whatever, sorry. Hello, I said no.
Thank you.
Right, and then we go to, we want a graph page. If you want to add a new thing, so now you're in a document, so it doesn't say Scratchpad, and so you have a, wait, oh my gosh. And so now you can put it in there, whatever. You can go back to Scratchpad by going to Home and then back to your Scratchpad, and so you can have more than one thing open and all the different things. Okay, so if you put it in your calculator, so the 2 points, so what it looks like, right? I'll kind of give the sketch. It looks like this thing, there's an asymptote right here, right? And then the other part is something like that, right? It's beautiful, it's great. It's ugly, but it's beautiful, right? At least I matched the colors, all right. So how could you find this point on your calculator? We're interested in this one right here. What tool?
Use the maximum.
Yep. So you can use the maximum to find this one. How can we find this point on our calculator? The minimum. Okay, so that's easy money. How do we find this point on our calculator?
Trace.
So you could use trace. That's absolutely true. You could use trace. You could use table. You could also use, algebra and be like, set the denominator equal to 0 and do that and get -3. That's about what I said. And looking at the picture. So it's definitely going to be at -3, right?
I saw it said error on the table. So
Right, yes. So that's what I'm saying. So you can use trace and if you're using trace, you're basically figuring out the limit, really, right? If you use trace, you can trace it and figure out that way and figure out the limit. You can use a table and figure out where there's an error or none or whatever your calculator says or whatever. Or you could use algebra and set the denominator equal to 0 and do that way.
Yeah, methods.
What?
I go to maximum.
Great.
So lower bound.
Bound.
So like. This
Lower bound would be to the left of the thing, of where you're looking.
Okay.
And then upper bound is to the right of where you're looking. And then it'll spit it out. It was on there
Oh,
a
I
minute ago,
see.
but then you moved it.
My bad. I'm great at this.
No, that's great. You're learning. You're doing things. You're figuring out your tools.
Maximum equals 6, -6, -12.
Yeah. And so and all we really care about for this problem is the x part, right? So what is the x part of this point?
X equals -6.
And then this one, the x is -3, right? What does the x equal on this part right here?
I don't know yet.
Okay.
I'm slow.
Oh yeah, it may be. Is it 0? Is that what you got? Yeah, that's what it looks like. And that actually makes sense because you'd find if it is the intercept, you'd set the numerator equal to 0. So 0, 0 does exist. So yeah, absolutely. So x equals 0. So it's increasing from negative infinity to this point, right? To negative 6. It is decreasing from negative 6 to negative 3, right? And then it is decreasing again from negative 3 to 0, and it's increasing from 0 to infinity.
Does it decrease from -6 to infinity because it doesn't ever touch the line? It just keeps going down.
Okay, so remember, so we're kind of talking about two. That's a great question, and it's easy to kind of get twisted up. So the interval part, we're talking about x, right? So we're really just talking about where it goes. We're not interested in how much it decreases. Like it's decreased. So all we're looking at is the x part, right? So it's decreasing from here to here, and from here to here. Did the book list all of that as one interval? I don't remember, but curious. What is this? Yeah, so it lists it as lists it separately, which is probably the better way to do it, because it does change, but it's still decreasing. Yeah. So intervals intervals between critical points, right? What other questions from this lesson? I know there were one or two other things that people asked about. This may have answered whatever you were confused about, possibly, maybe not. 8.
Or are you looking at, on 8, is there going to be 4 different things because it's 4?
1, 2, 3, 4. Yes. Yes. Yeah, that's right. That's right. That's exactly right.
I'm confused on the decrease from -3 to 0.
That's from here to here. So it's still going down from that part, right?
What the heck?
Yep. What other questions from this lesson? Anything else? Did you say one earlier? No?
6.
Oh, great. Great.
And also, all I did was just misunderstand what exactly we were supposed to write down. So I knew what I was doing, I just got it.
That's not unusual in pre-cal because it gets funky.
And also, I interpreted the based off the graph as you have to just look at the book and be like,
Right. Well, and you could, yeah, I mean, yeah, it's easier if we use all the tools, but yes, that probably is what they meant, but this seems more reasonable when we have the tools.
How did you use the trace to find the sides? Or find
So if you use trace, you can just trace here and see and you're looking for the limit, basically. What x value is it getting closer and closer to? So as you trace, like if you start here and you trace and you keep tracing, it's going to get closer and closer to -3. If you use the table, you can see that there's an error at -3. So if you pull up the table, you can confirm your suspicions. Did you hear me? Pull up the table, and then look at -3. So that confirms that is in fact what's happening. Yeah, it's not really. It's kind of almost a reverse limit because we're talking about the x part instead of the y part. So yeah. All right, let's look at the next lesson. Parent functions. That reminds me. It's a few weeks out, but a week from Thursday, the video is there. I made it. It's done. The assignment's even there, unless I'm mistaken, which I don't think I am this time. This time I think that I did right, which would be grand. It's an hour and 5 minutes long. So you may want, the reason I'm telling you now is you may want to start it early.
It's due for works.
Not this Thursday, but like after the day, it's the class after the test. So,
You're evil.
no, pre-cal is just bloated. That's just how pre-cal rolls. That lesson in pre-cal is like 3 or 4 lessons in algebra 2. It's not this book, it's pre-cal.
Who
This-
wrote pre-cal?
Right, well, you know, that's, I don't know, some teachers probably, honestly, because they were looking at calculus and was like, we need a little bit more prep to make sure people have the algebra. Because if, you know, and I don't know whether anybody in here will, but if you end up taking calculus in college, you will discover that the only people that have trouble taking in calculus are the people that where either their algebra or their trig is not very strong. Pretty much nobody for most of the calculus topics has trouble with the calculus part. Because the derivatives are easy, like easy money. You can look at it, tell me the answer.
Do you have to do calculus for accounting?
Depending on your program, you're probably more likely to have to do business math, which are actually harder classes. I tutored a bunch of people. You'll do fine, but I tutored a bunch of people in those classes. Where's my phone? Because I need pictures. There it is. Because those classes are always funny because they make business majors take business math 1 and often 2. And business math 1 is like pre-cal, basically, without the trig. It's like all these word problems. It's super hard. Definitely harder than college. Definitely harder than college algebra. And they're making business majors that didn't really want to do math. That's why they took business, take these classes. And then business math 2 is like Cal 1 and Cal 2 shoved into one class with applications. It's an awesome class, but it's hard.
The only reason people don't like word problems is because they only learn how to stick stuff in a formula and they're not sure what they're even doing.
We are on the same page, girl. I agree with that 100%. That's exactly right, which is why I teach word problems the way I teach them. Which is not the way I learned them in high school. My teacher was great, but on word problems, I honestly thought I was bad at math until I went to college algebra and realized, oh, maybe I'm not actually bad at math. Let's see, what problems did we do on 1-5?
2, 4, 10, 14, 20, 24, 28, 30.
Heaven help us. Did you say a lot?
Yes.
Okay, 2, 4, 10. All right, number 2. The domain cannot be 0. Other than that, it's all real numbers. The range cannot be y cannot be 0. The graph has no intercepts. The graph is symmetric with respect to the origin, and the graph has an infinite discontinuity at x equals 0. The limit as x approaches negative infinity is 0, and the limit as x approaches infinity is also 0.
Is that the end behavior?
Yes, that's the end behavior. And then the graph is decreasing on negative infinity to 0 and on 0 to infinity. Number 4, the domain is all real numbers. The range, y is greater than or equal to 0. The graph has an intercept at 0, 0. The graph is symmetric with respect to the y-axis. The graph is continuous. And the limit as x approaches negative infinity is infinity. The limit as x approaches infinity is also infinity. The graph is decreasing on negative infinity to 0 and increasing from 0 to infinity. Am I reading a bunch that we didn't do? That we did all those so far. Now number 10, here we go. Where's it?
We have to draw stuff.
You got to draw stuff, and it's going to be back here on the other page. Why didn't I stick something in there? Who knows? Nobody knows. 1, 5. Number 10. There it is.
I didn't know it did.
I just stuck it in my graphing calculator and don't know that.
Is this parent functions?
Yes.
This is easy money, y'all.
So I thought too. I was so excited for something easy, and I looked at it and I was like, brain shut off.
It's easier than you think.
Probably. It's usually how my life works.
Number 10. Oh my gosh. Got this. Number 10 is right there. Parent function is f of x, and g of x is the transformation. And did we do 14? Is that the next one we did?
Yep.
Okay. I think that's on this. Yes, it is. A little bit, that's actually less blurry on there than it is on here. There is 14. It's hard to look at, hard to see what's going on. Let me grab something to shove in here. The f of x, which is, I don't know why they didn't do it in like gray or something. This is f of x, this one, and then the g of x is the transformed one, which is over here. What number did we do next? 20.
With our answers on those two, were we supposed to draw the parent function as well?
Let's see what the instructions say. Instructions say use it to graph each function, so you didn't necessarily have to, although it might be easier. So you didn't necessarily have to. Okay, number 20. Describe how the graph is related, and for some reason it's over here. Number 20 is invisible. Oh, it's because it's on the next page. Great. Number 20, the graph of g of x is the graph of f of x translated 8 units to the right. And the equation would be g of x equals the absolute value of x minus 8, all of that inside the absolute value. And then what do we do next? 22? 24. Great. Sounds, oh yeah, that makes sense. I know what I was thinking. All right, number 24, the parent function with the absolute value parent function, so f of x equals the absolute value of x. The graph of g of x is the graph of f of x expanded vertically and translated 4 units down, and it looks like this. Thumb thrown in for free. Oh, it's a little blurry. Can we see that well enough? Leave it. Let's get through all the things, and then we'll come back to it. Put a mark on it, and we'll definitely take a look. What was the next one we did? 28. Greatest integer function. Also know what I was doing there. Okay, great. 28 is the graph of f of x is greatest integer of x. Graph of that probably has a hello. The graph of g of x is the graph of f of x translated 2 units down, to the right and expanded vertically and reflected in the x-axis. Look at all that beautiful change. And when you graph it, also is going to be a little tricky to look at because they put that on there, but it looks like, the one labeled g of x, what's that like expanded one? Not the pretty little tight stair-steppy one. The one going backwards. Okay. And then did we do one piecewise function, right?
34.
34, beautiful. Number 34 would look like something. There it is. Oh, look, good choice, me. I like that choice of a problem. That was a decidedly good choice. Where did it go? Just kidding, I was looking at 33. Well, that's also a decent choice. I like 33 better, but oh well. It should look like that. All righty then. What questions from that lesson? Oh yeah, that one. It was number
24 and 28, maybe? I don't know.
Yeah, 28.
Why, okay, so it starts off like this, and then it goes to that. So how is that expanded and not compressed?
Okay, so I talked about that in the video, but I'll talk about it here too. So
I didn't understand what was in the video.
it's totally fine. It's why we have in-person part of this class. If you didn't need this part, then I would just like put out the lectures and leave. 3 times the absolute value of x minus.
Okay, so I know, I understand the math part of it. I just don't know why the name is compressed whenever it looks like it's not compressed.
It's expanded. It's not compressed. It's expanded. This one is expanded.
Why is it called expanded?
Okay, so it is a vertical expansion, not a horizontal one. So it's. Pardon me. This shirt is a little small. Let's see if I can not expose my whole belly. So it is expanded vertically, so it's stretched up. It is, if it was in horizontal, it's pushed in. So it's not this, it's this. So it's going up vertically. And it would compressed vertically is squished down like this.
Oh. So
Yeah.
this word's being stupid.
Yeah, it's hard to look, because it looks like, and that's what I talked about in the video too, is it looks like it's compressed because it looks smaller, but it's stretching up to the sky, right? That's what happens.
Okay. Any questions on anything else while you're on?
Okay, what do we got?
Let's start.
Do we want to look at the piecewise function, or is there another one that is a more pressing need first?
I just don't understand what to do in general.
Math.
Yeah, let's do the piecewise function. Let's do number 8.
You mean 34?
Oh, yeah, wrong page. Sorry, 34.
Yeah, let's do 34. Because I would argue that that's the trickiest bit on there. Or if x is less than something. Negative. Is it? Yeah, it's just less than -5, and it's x cubed. If x is between -5 inclusive and some other number, presumably. Oh, just kidding. That's not what it is. Oh, that's a even more exciting piecewise function, because precal. And it's the square root of x plus 3 if x is greater than something else. 3. Greater than 3. All right, we have 3 pieces to this piecewise function. They have 3 different definitions depending on where we are. And actually, there's kind of almost more pieces than that, because they don't overlap. There's some gaps in this function, right? There's kind of even more, not inflection points, but dotted line points, right? So the points of interest are at -5. We have 1, 2, 3, 4, 5. So here, and what my recommendation still is to go ahead and add some dots in there just so you can see where we're looking. It's easier for our brains to think about it. Now we have some extra things, because we've got it at -2. It's not the middle chunk doesn't overlap with the other chunks like is typical previous to this. And then at +2, we've got another point, another section. And then again, we have a totally different point at 3 where it's changing, right? There's a lot of things going on here. But if we break it into pieces, so it might be useful, since there's all kinds of things, thinking, okay, so where is the graph? So there's 1, 2, 3, 4, 5 segments, but the graph is going to exist in 3 of them. So where does the graph not exist? Because we might want to put X's to help us remember we're not interested in those segments. Which ones of these chunks is there not going to be a graph?
-2, -4.
So between here and here, there's not going to be a graph.
And 2 and 3.
And then there's not going to be a graph right there, right? Because there's no definition in there. Okay, so it might also, we'll do this to the side. Let's throw in something else. look at each one of these segments and figure out which parent function goes with that definition. So what parent function goes with this one? Yeah, what's that called? Constant. Okay, so the parent function looks like this. Okay, what parent function goes? That one literally is the parent function, right? Yeah, cubic, and it's going to look like this, right? What parent function goes with this part? Yeah, the square root, and it looks like that.
The what?
Square root 1.
What is that symbol? Good, I'm glad. So this one, what is it going to look like over here? So we've got 4 over here, we've got x cubed in here, and we've got square root of x plus 3 over here. What's it going to look like right here? A straight line at 4. Easy money. Go up 1, 2, 3, 4. Is it going to be a solid circle or an open circle? Open circle.
How do we know?
You tell me. How do we know? What from this first line? I said he tell me. What from here tells me?
The greater than and not equal to.
Perfect. Great. Which is exactly what she was about to say. Good job, team. And then it's just a straight line. Headed out this way, huh? Great. There's nothing in here. There's nothing between 5 and -2. We don't have a fourth definition in here, so we're going to jump over to here. So this one is the cubic parent function. So, and it's also the one that's sitting at the origin. So, and it's just the parent function. So where can we put some dots in there? 0, 0, 1, 1, and -1. -1 sound beautiful. And then we do our best to S-curve it in there. Except it's not going to have a line. Those, does it have open? Oh, what is going on there? What should be there? What should actually be there? Thank you. That's what I thought it was from remembering the picture, but I guess I could have just looked up there. That's equal to 2. So it's got solid dots. Now we need to figure out where those dots are. That's the only other bit that really needs to happen. Okay, so how can we figure out where this dot goes and where this dot goes? Yes.
Problem.
Yes.
-2 and 2.
Yeah. So we're going to plug these one into here and these one into here and see what happens. So -2 cubed is what?
-8.
True facts. So this one is at -8. So -1, 2, 3, 4, 5, 6, 7, 8. It'd be better if I had graph paper, but you know, the best we can. Those are filled in circles. And then the other one's going to be what? +8. True enough. 1, 2, 3, 4, 5, 6, 7, 8. You know, words I'm trying to say. All right, there's nothing in this little chunk, but there's something over here. How is this transformed from the parent?
It's going to the left 3.
To the left, it is shifted to the left 3. That is all accurate. Are you pointing to the left 3? Okay, so this would, if we were graphing the whole thing, it would be over 1, 2, 3, and it'd be. So probably somewhere over here is going to be a. Probably pretty flat by that point. So we need to figure out where to start here. 3 into these one. True enough. So the square root of 3 plus 3. What's 3 plus 3? 6. Shame it's not 9. So that's approximately equal to what? 2 point something. It's a home button or something, I imagine.
2.449.
Is there a short?
Maybe
Second
escape.
split.
Well, yeah. You can press the apps button and then go to the home. But is there like a shortcut or something? Like
Which
a
one?
best calculator or something?
I bet there's a. Is there a
2.45.
2.845? Is that what you said?
2.45.
2.45. That makes more sense. Yeah, home right there. There it is. I figured there. I figured there was a shortcut. 2.45. So at 2.45, there is an open circle. We probably want a point or two out here. So to go to your table or shove something in there or to do something, you could potentially put a 6 in there and make it the square root of 9. So that would be 3. So 6, 3, which is probably plenty to be moving on with. Yes. 1, 2, 3, 4, 5, 6. And then 1, 2, 3. So as we predicted, it's just kind of barely going by this point. And then there's that graph. Isn't it beautiful? Isn't she lovely?
Who's that by?
I don't know. It's kind of old-ish.
Why did we shift it up?
We didn't. We did not shift it up. So if this wasn't piecewise and it was just this one, then it would be this. So we didn't shift it up. It just starts partway through it. Yeah, that's a good question. Yeah, that's a really good question. Any other things from this lesson?
Am I allowed to ask a question about number?
No, just kidding. Probably yes. What about number what? Time it. Better make sure our time is good
I
before.
feel like I should know this. Why is it not coming to my brain?
Which one are you looking at? Tell me what you're talking about.
Freaking number 2 through 6.
2 through 6?
Yeah. 2, 4.
That one you just pull straight from the chart, right?
Chart?
Yeah, the number 2. Yeah, the table that where do we talk about the parent functions? So it's number 2 through 6 is just what is the parent function? What is the domain and range of the thing and whatever else? Just like read from your notes and write down your notes on that particular parent function, basically.
But we also have to find the intercept and symmetry and continuity.
True enough.
Continuity. I don't know why that word doesn't work. And behavior and
Yeah. Same as the other, yeah.
Can we do that one really quickly?
What one?
2.
Yeah, what does that parent function look like?
That is, I guess, an identity.
It's definitely not an identity. That is definitely false.
Oh,
It is reciprocal. What does it look like? This is what you're doing. Is that what you're? Well, that is definitely not what it looks like.
What?
That is definitely not what a reciprocal parent function looks like. Not at all. Yeah, it looks like that. I mean, it looks what you're trying to do. Yeah. So it looks like this, right? Great. What's the domain?
Big chunk in the middle that's missing.
Yep. So what can X not be?
0.
Great. What's the range?
Everything but 0.
Right. Y cannot be 0. Great. Did it. What is that? What is X not in this picture? Look, Mina. What is it? Where does X never go? Where does this graph never go?
It never goes 0.
Great. So the domain is, so depending on your notation, if we use separator notation, it's X such that X does not equal 0. X is a member of the real numbers. So if we use that notation, it's that way. If we do interval notation, it's negative infinity to 0, not including that, unioned with 0 to infinity. Any of those options is great. The range is going to be the exact same thing, except these will be y's because it also never gets to 0 this way. Right? Great. Next thing we're supposed to ask is, Intercepts. It doesn't have any intercepts. It never gets to any of the axes. Great, done. Now, next thing is symmetry. Is it symmetrical in any of the three ways? Which way is it symmetrical?
The do-do.
Yeah, the do-do. What's that called? What's the right word? It's the same name as this origin. True enough. Okay, great. Next thing, continuity. Is it continuous or discontinuous?
Discontinuous, because there's giant hole.
Yeah, what kind of discontinuity? Infinite discontinuity, because it and in the next unit we'll see ones that look like this. In fact, you'll see it in the video. Same thing, but a little different. Great. What else were we supposed to say?
And interval.
In behavior. As it approaches negative infinity, what is it getting closer and closer to?
Negative infinity.
No, on the y part.
Oh, zero.
Zero. As it approaches positive infinity, what is it getting closer and closer to? Zero. Great, we've done it. Now, one more thing, I think, if I'm not greatly mistaken. Yes. Where is it increasing?
From 0 to infinity.
Oh, that's a trick question. It's never increasing.
Oh, right.
Yeah, I know exactly what you're answering, but I gotcha. It is.
My brain cell that is increasing, I'm not even sure.
I don't know if it, I think you just thought I was asking a reasonable question because I was moving quickly. And you answered what you thought I was asking instead of what I was asking. Good job, me. Ha ha ha. Okay, so it's decreasing from negative infinity to 0 and then also from 0 to infinity. All true. Great, we did it. Let's do the next lesson before we run out of time. All right, what numbers?
Hands are half numbers.
A million, yeah, 1.5 million numbers. There were 5. That's not 1.5 million.
On the
Oh, I follow you. All right, number 4 is somewhere.
There's 4 answers.
Yes. Ha ha ha. Okay, so number 4, f plus g is 2x minus 4. The domain is all real numbers. F minus g is negative 14. The domain is all real numbers, which might be a question. I could see that. F times g is x squared minus 4x minus 45. The domain is all real numbers. And f divided by g is x minus 9 over x plus 5. And the domain is x cannot be negative 5, written in the method of your choice. And then we did what number? 12? 12 is a different page. Fool me once, shame on you. Fool me twice, shame on me. So we have moved to the shame on me phase. Great job. Of course, it's my own brain fooling me, so does it count? I don't know. Probably. 12 plus is square root of x plus 6 plus the square root of x minus 4. The domain is 4 to infinity, including 4. The minus is square root of x plus 6 minus the square root of x minus 4, and the domain is also 4 to infinity, including 4. The times is the square root of x squared plus 2x minus 24. The domain is still 4 to infinity, including the 4. Excuse me. And the divided by is the square root of x squared plus 2x minus 24 all over x minus 4, and the domain is 4 to infinity, this time not including the 4. Number 16, f of g of x is, excuse me, negative 50 x squared plus 145x minus 101. And g of f of x is 10x squared plus 25x plus 1. And f of g of 6 is negative 1,031.
1,000?
That's what it says. Although, as we know, there are mistakes in this key sometimes, so who knows? We can look at it if we need to. Number 22, f of g of x is 2 over x squared plus 3. And 28, f of g of x is the square root of x squared plus 6. Questions from that lesson?
On 28, can you not separate out the two things and then the square goes away on the x?
No, you couldn't. If it was timed, it was multiplication, you could.
Oh, you can't do it with.
Right. Yep. What other questions from that lesson do we have?
Doesn't have brain up.
What?
I don't understand. My brain just doesn't work.
All I know is I got my answers for these two, and I'm not sure what.
On that one you were asking me about?
No, this is a different one.
Okay, which part of 22 and which part, the multiplication part or the
I don't know, my answer's just not.
didn't seem to match?
I
Okay.
don't-
So 22 f times g of x is what we need to look at. Does that sound right?
It's f of g of x.
Oh, f of g of x. Make sure it's like a not filled in looking circle, because then it looks like times. Okay, f of g of x on 22. Okay, let's look at it. Don't forget, getting things wrong doesn't make you wrong. Number 22, f of x is 2 over equals 2 over x minus 3, and g of x equals x squared plus 6. And we're supposed to find f of g of x, fog. All right, so f of g of x. So we would take g and put it inside of f, right? So let's do that. So it'd be 2 over, and then all of that junk inside of that one. So x squared plus 6 minus 3. Now what would we do?
Solve it.
We would combine.
Simplify it, actually. But yeah.
In the terms of like the parentheses, is that counted as a -3 and you multiply it onto the
No.
parentheses?
No. And these parentheses don't do anything in this particular problem. The only time they would is if there was something multiplied. It's just best to stay in the habit of doing it, of putting the parentheses. Does it ask anything else? Is this different than what the key said? Who knows?
As simple as it gets.
I think that's as simple as it gets. I don't see any way to simplify it.
I messed up the adding the thing. Okay. 16C is the best way I can say it, because I really don't know that.
The times part or the divide part?
The one with the 6.
The 6, let me see. Let me make sure I'm looking at the same problem as you, and then we can all understand. Oh, at the end, the f of g of 6,
Yeah.
that part. Okay, great. So I've got to find f of g. Oh gosh, almost died. Would have been tragic. F of g of x on these one, you said 16?
Yeah.
Okay, so f, I'm going to go straight to this on the board. Save ourselves time and trouble. So we're going to shove g of x inside. So -2 times -5x plus 6 squared. And then -5 times -5x plus 6, and then plus 1. Okay. On this first one, we can do the shortcut to square that. -2, then times this squared would be 25x squared, and then 2 times this is going to be negative 12 times 5 is 60. So 60x, that sounds right. If I made mistakes, let me know. And then last is this squared, so plus 36. And then we can distribute this.
60 isn't right.
I think it is, but let's see if I'm wrong. We'll do it the long way to,
Wait, how did you get the 60?
because, so the shortcut is a squared plus 2ab plus b squared.
Yes.
So 2 times 6 is 12, times 5 is 60. But we'll double check it with long cut real quick, just to make sure that, and sanity check our way through things. So that would have been the outside and the inside. So this times this is negative 30x. And this times this is negative 30x. So still looks like negative 60x, I think. I think that's still accurate. Okay. And then the next one, distribute. So negative 5 times negative 5 is plus 25x. And the negative 5 times 6 is plus 30, and then plus 1. And we got to distribute the 2. So negative 50x squared plus 120x minus 72. Sound accurate? Plus 25x. We'll go ahead and combine those to plus 31. All sounds accurate. I am going to underline what we're doing. So for my brain, this one doesn't have a friend. Negative 50x squared plus 145x minus 41. Does that sound accurate?
72.
Y'all are making weird faces, so I'll sanity check myself.
Is that 30 not negative? I'm pretty sure it's negative. It's negative 5.
Ah, yes.
Regular 6.
So if I would have been right up to that point, it would have been right, but it's not right. So this is actually negative 29, negative 101. All accurate. So the answer to the first question was right. I just didn't realize there was another question to be asked. Okay, so now we're supposed to put 6 in there. Which is a bit obnoxious, but we got this. So the first one would be negative 50 times 6 squared, which would be negative 1800, according to my calculations. If y'all discover that I've done it wrong, just holler. 5 times 6 is 870 minus 101. And then all of those things, negative 1800 plus 870 minus 101 is negative 1031. Did you make a little mistake somewhere?
No, I didn't do it that way. I went ahead and put in the 6 at the very beginning in all the x's.
So probably you just like punched plus instead of minus or something. Who knows? Making a mistake doesn't make you wrong. It can be frustrating. That's allowed. But it doesn't affect your person. Well, if you let it. If you don't let it. Any other questions from this lesson? What are you doing?
I'm being bored.
Okay. All right. What time is it? Let us see. It's time to leave. Kind of what I figured.